About hydraulic fracturing, and there's an awful lot of misinformation about hydraulic fracturing. A lot of information to the point of a lot of people really aren't even sure what it is. And so I want to straighten out a few of these things right here. What is hydraulic fracturing? First and foremost, it's a well completion process. It's not a drilling process. It's a way in which you complete a well so that you can extract natural gas from otherwise what we call tight formations. It was developed in the late 1940s. It basically uses water as a medium to induce hydraulic pressure on the formation, and it creates fractures in the rock, which allows natural gas, oil, other liquids to flow out of that rock, which otherwise would not be productive. It obviously improves the production of the oil and gas. It's been successful on more than 1 million wells in the United States and more than 85,000 wells right here in Ohio, and most of those are concentrated in eastern Ohio, right around where we are right now. Some of the basics on hydraulic fracturing. With the shale gas development, it's been combined with horizontal drilling technology. And what that enables us to do is, rather than just drilling through a formation that might be 150 feet thick and having access to 150 feet of that rock, you can turn the wellbore horizontal and drill out through the length of the formation as much as 5,000, 6,000, 7,000 feet. And that way you increase the surface area from which you can produce. Once you've drilled out the formation, you run protective casing, production casing. You cement that casing back. After the cement is set up, you run a perforating gun. It perforates through that steel casing, through the cement, and into the rock formation. Once that's complete, you pull the perforating gun out, and then in stages, you go in and you perforate, or you go in and you hydraulically fracture the formation using large volumes of water, large quantities of sand, and certain chemical additives that affect the way the hydraulic fracturing fluid works. What's the frac job look like? Here's a site from Marcellus up in northeastern Pennsylvania. And what you can see from this site is it's large. It covers a good amount of area. This particular site that you're seeing here is a little bit smaller than others. It might only be 2 to 3 acres in size. And the reason why it's smaller, it doesn't require a frac water containment pond. If you look down in the lower right-hand part of the picture, you might be able to see a little pipe coming up out of the woods. That's actually the water supply source for the hydraulic fracturing that's going on in the picture. You can also see that the hydraulic fracturing operations is fairly complex. It requires a lot of different technologies, a lot of different personnel, a lot of different vehicles, different equipment. They're labeled on here so you can look at them. But overall, it's a pretty high-tech type operation. Here's another site. This site did not have a containment pond nearby, and so it could not supply water via a pipeline. Instead, the water comes by way of frac trucks. And if you try to count the trucks in there, I think you'll get up to about 100 and start losing count of them. Because of the enormous quantities of water, you need a lot of trucks to haul this water in. To talk a little bit about the geology, and I'll come back to the hydraulic fracturing in a minute. What you have here is a generalized section that shows the relationship of the Utica formation to the other formations that overlie it. A well penetrates vertically, and about 500 feet above the target formation, the Utica in this case, it starts kicking out, gradually working its way to a 90-degree angle. In order to do this, you change your drilling technology from rotary to mud motor. And you can gradually change the angle of the hole half a degree at a time until you get out to horizontal, and then you continue drilling with that mud motor down the center of the formation. If you think about it, it's a lot like threading a needle. Not that easily done. So we're looking at, again, pretty high-tech type stuff. The other thing I want to point out in this picture is that the separation of the target formation, the Utica, from the surface, the groundwater, the surface waters, is immense. In our area right here, you're looking at about 7,000 to 8,000 feet. And that rock that separates the Utica from the surface is largely impermeable. And one zone in particular, the saline salt, which is anywhere from 50 to a couple hundred feet thick, is totally impermeable. I'll come back to this in a moment, but one of the things I'm getting at is when you hydraulically fracture, there is no physical way that fractures can extend to the surface and bring frac fluids up to contaminate our groundwater. An important part of the process is how the well is drilled and completed. All oil wells require multiple, what we call strings of casing. It starts with a conductor casing that's basically drilled to stabilize the well so they can continue drilling. Conductor casing that's used on Utica wells is 20 inches in diameter, and it'll extend to whatever depth it needs to, generally down to firm bedrock. Once they set that casing, they put a shoe on it, and they pump cement up around the outside of the casing between it and the wellbore to seal that off. The next thing they do is they go with a smaller bit, about a 13.5-inch bit, and they'll drill down at least 50 feet below the deepest aquifer or freshwater producing zone, groundwater. They'll do the same thing. They'll run the casing, they'll run a casing shoe and pump cement all the way up to the surface, let that cement set. The next thing they do, they go in with a smaller bit. They drill out that cement, about a 9.5-inch bit, and they continue to drill down all the way to the formation target. If they encounter different or abnormal formation pressures, they'll run what's called an intermediate string to seal off those formations. They'll cement it back. The cement typically does not go up to the surface. The final string or drill they'll do with even a smaller diameter. They go in, drill out that cement, go down, kick out to the horizontal, drill the entire length of the formation, and then they'll set the production casing. That casing goes all the way from the surface to the very end of the hole. Typically, this is 12 or 13,000 feet in length. They cement it back well above the top of the formation and let that cement set. One of the points to be made here is that the shallow horizons, your groundwater, your surface water, are protected behind 3 and likely 4 different layers of casing, and up near the surface, 2 layers of cement. How does the process work? I've got a couple slides here that maybe you've seen on National Geographic's website. They're really nice graphics. But you go in and you drill. In the second picture, the production casing is being run into the hole. Once the production casing is in place, you come in, you pump cement. That cement runs between the casing and the actual annulus, or what we call the wellbore. And once that is all set, you then run a perforating gun. And the perforating gun, these are pretty interesting. They're also dangerous objects. But it's a gun that comes in different sections. It's a tool, cylindrical, and it's got 1.5-inch size bullets, at least the ones I've looked at have. And those bullets have a charge behind them. And that charge will actually puncture an 1.5-inch diameter hole through the steel casing, through the cement, and fairly deep into the formation. And then what that does is it provides an avenue for the fracturing fluids to get into the formation.